Okay, today we're going to talk about moles and reacting masses. Welcome back to A-Star Science, part of our GCSE Must Know Chemistry series. Remembering that a mole in chemistry is just a unit of amounts. The best thing to compare it to, for example, is if someone said 1 dozen, 1 dozen we know equals 12. Okay, whereas with a mole doesn't equal 12 because that would be too small. A mole equals 6.02 times 10 to the 23rd units. And that could be, for example, 6.02 times 10 to the 23rd molecules. It could be 6.02 times 10 to the 23rd atoms. Okay, any of the units, the different particles and different substances that we talk about in chemistry, 1 mole would represent 6.02 times 10 to the 23rd of those things. And so this is how in chemistry we use moles to look at amounts of substance. Now, how do we use this in calculations? That's what we're going to show you now. And I'm going to show you my patented favorite method, which is I call the table method. A lot of people find moles quite complicated and calculations, quantitative calculations, quite complicated. But if you use my table method, you're going to find it much easier. You're going to get the 7s, 8s, and 9s that you want to get. Even you can use this for A-level chemistry. So let's just take a example equation. Let's take, for example, hydrochloric acid plus sodium hydroxide. And that's going to yield acid plus base, a salt. In this case, sodium chloride plus water. Acid plus base yields salt plus water. And we're going to look first and make sure it's balanced. So we can see on the left-hand side, there are 2 hydrogens. And that matches on the right-hand side, 2 hydrogens. 1 oxygen on the left, 1 oxygen on the right, 1 sodium, 1 chlorine. Everything is balanced. So let's say you were given 10 grams of hydrochloric acid and you wanted to know how much sodium hydroxide, what mass of sodium hydroxide would be needed to react with that 10 grams. So the table method, the first thing you do is you write out the equation, which we have done here. We've written out the equation. And the next thing you're going to write down from the exam what you know. So here I've given you a mass, so we know that. And the next thing you're going to write down what you're trying to figure out. So in this case, we're trying to figure out the mass of sodium hydroxide needed to react with that 10 grams. So we can look at moles to help us with this calculation, because what this is saying, this equation, is that 1 mole, this is 1, even though we don't write the 1, this is 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So that means it's a 1-to-1 ratio. So if we can figure out how many moles of hydrochloric acid we have from the 10 grams, we could figure out how many moles of sodium hydroxide we're going to need, and thus the mass of it as well. Okay, so we're going to use this equation. Very, very useful. You're going to need that. You go into your exam, you write this on the paper. Mr. Mole mass. Mr. Mole mass. Mr. in this case stands for the molar mass. And we'll talk about what that means in a minute. So in order to find the moles, we see that we need the mass divided by the MR. We have the mass, so now we just need the MR, the molar mass. And if we see hydrochloric acid, we look in the periodic table. Hydrogen is worth 1, the mass of hydrogen. Chlorine is worth 35.5. Okay, which in total equals 36.5. That's the MR of hydrochloric acid. So the MR of hydrochloric acid is 36.5. We can work out the moles by doing moles is equal to the mass divided by the MR. And the mass we said is 10 grams divided by 36.5. You get my calculator. You all can follow along with me. So that's 10 divided by 36.5, which is 0.273, long number, but we're just going to use part of the number, 0.273. That's fine. I'll stop it there. And that's how many moles we have of water from the 10 grams. Now we said it's a 1-to-1 ratio. So now that means we also are going to need 0.273 moles of sodium hydroxide. Notice how I'm doing it and why I call it the table method. Because if you look, this is the column here for hydrochloric acid. And that means that this is going to be my column here for sodium hydroxide, like a table. Okay, so we have the moles of sodium hydroxide. Now we want to find the mass. Well, we can clearly see from the triangle, formula triangle that we have here, that mass is MR times mole. So all we need to do is find the MR of sodium hydroxide. Sodium is 23, oxygen is 16, hydrogen is 1. So 23, take the calculator, plus 16, plus 1, that's 40. It's going to equal 40. And so we know that MR times mole is mass. So if we multiply that 40 by our answer, 0.273, we get 10.92. That means it's going to, our answer is going to require 10.92 grams of sodium hydroxide to react with the 10 grams of hydrochloric acid. And if we wanted to, we could find out how much sodium chloride would that produce. We could find out how much water would it produce by following this same method, which I call the table method. Now let's look at one more example, because sometimes the moles do not always act as a 1-to-1 ratio. But if you follow the same steps that I just followed, it would be quite easy. You just clear the board. You can rewrite this again. Our formula triangle. Do a bit of knowledge retrieval. What's the formula? Mr. Mole mass. That's the formula to find out moles. So let's look at a different equation. Let's look at the combustion of methane. Combustion of, this is methane here. Combustion means it reacts with oxygen and it's going to form carbon dioxide plus water. In this case, carbon dioxide plus water. And to balance it, I have 4 hydrogens on the left. So I'm going to need to put a 2 in front of here to balance it. Now I have 4 hydrogens here and 4 hydrogens on the left. I have 2 oxygens on the left and I have 4 on the right. So I need to put 2 here to balance it. Let's take a quick check. 1 carbon on the left, 1 carbon on the right. 4 hydrogens, and 4 oxygens. So it's all balanced now. But notice now our ratio of methane to hydrogen is 1 to 2. 1 to 2. So what do we do in situations like that? Okay, we're going to do the same table method. Let's say again, we had 10 grams of methane that was given to us. So we're going to write mass on this side because that's what was given to us. We need to find the moles. Okay, and to find moles, we know we need the MR. Well, the MR of methane is 12 for carbon plus 4 for hydrogen because it's 1 times 4, and that's going to equal 16. Okay, 16. And to find the moles, we're going to take the 10 gram divided by the 16, because as we know, moles is mass over MR. So if we now use the calculator, 10 divided by 16, 0.625. 0.625. Our moles equals, change the color of the pen. Our moles equals 0.625. But let's look. Let's create a little line here. We know that it's a 1 to 2 ratio. So this is 1 to 2. In other words, for every 1 methane, there are going to be 2 moles of oxygen. For every 1 mole of methane, there are going to be 2 moles of oxygen. So I'm going to multiply those moles by 2. So 0.625 times 2 is 1.25. 1.25. Now I'm trying to find the mass. This is what I'm trying to find. And so I need my MR. MR of oxygen of O2 is 16 times 2. We don't include the 2 in this case. We only include that for the molar ratio. So 16 times 2 is 32, as we know. And the mass is the MR times the mole. So that's going to be 40. That's the answer. We would need 40 grams of oxygen for every 10 grams of methane. This is what I call the table method. And of course, you can use this method to also calculate the mass of carbon dioxide needed and the mass of water, not needed, sorry, carbon dioxide produced, and the mass of water that you would produce, remembering to look at the molar ratios. Many of the calculations you're going to use in chemistry, reacting masses, limiting yield, titration calculations, you can use the same method to calculate amounts of substance utilizing Mr. Mole mass, utilizing moles. My patented table method.